All right, a rational expression is the quotient or a ratio, so the word rational has as its root the word ratio, of two polynomials. Okay, so for example, a rational expression that describes the cost in millions of dollars to remove X% of the pollutants that are discharged into a river is this expression here, 250X over 100 minus X. Tells you how much it will cost to remove X% of what is there. Switch your table, take a couple of minutes, do it on your own first and then check with a neighbor. I want you to use that expression to find the cost to remove 20% of pollutants and then say what percent can be removed if we're willing to spend $375 million. So find the cost in millions to remove 20% of the pollutant. What do people come up with? 62.5? 62.5? Okay, so I have to put in 20 for X because X represents the percent of pollutants. So I'm going to do 250 times 20 over 100 minus 20, which is, I think, 5,000 divided by 80, which is 62.5. And this tells us in millions of dollars, right? So this is $62.5 million. Okay, so how much can I clean up for 375 million? So now I need to, I'm going to be solving for X, because what percent can I clean up? They're asking me what for an X value. So now I'm going to take my fraction, my expression, 250X over 100 minus X, and set it equal to $375 million. Okay, how do you solve this thing? I know some people solved it. Yeah, Nico? Okay, so I have a denominator, right? The 100 minus X. Don't you just hate fractions? You just hate them, right? They're the worst. So my first step is going to be to get rid of the fractions, right? So I'm going to multiply both sides of the equation by 100 minus X. Multiply both sides by 100 minus X. And the whole purpose of doing that is that when you multiply 100 minus X times this fraction, I have one in the numerator, one in the denominator, and they just go away. So I'm left with 250X equals, now I have to multiply 375 times 100 minus X. And you just do that by distributing, right? So you get 3,750,000, I don't know, add 2 zeros, 37,500, right? Multiply by 100, just add 2 zeros. And then minus 375X. And now we just have a linear equation to solve. Add 375 to both sides, and you get 625X equals 37,500. Divide by 625, and you get 60. So 60% can be removed for $375 million. So if I wanted to do this really fast, like if I wanted to know the cost to do 30, 50, 80, 90, 95, 98, 99, I just want to know a whole bunch of costs really fast, I can use my calculator to do this quickly. Or something like GeoGebra or whatever graphing device you have. I'm just going to use my TI because I have one here. If you're using a different device, it will be your responsibility to figure out how to do these kinds of things. Okay. All right, so what I'm going to do, follow the directions here. It says press the y equals button. I need to put the expression 250x divided by 100 minus x in there. And whenever you're dealing with a rational expression, you should put parentheses around the whole numerator and the whole denominator because your calculator knows the order of operations and it might do something wonky if you don't do that. Okay, so now I'm going to go to my table set, second window, and make sure my independent variable is set to ask and dependent is set to auto. Go to my table, and now I can type in anything I want. I'm going to type in 30, 50, 80, just typing in X's and it's telling me the Y's. Okay, so I can plug things in quickly. 90, oops, 90, 95, 98, 99. Okay, so copy these down. 107.14 million, 250 million to do 50%. 80% is 1,000 million. How much is that? A billion. 1,000 million is a billion. Yep. 2,250 million. That's 2,250 million. 95% is going to take $4,750 million, or 4,750 million, or 4.75 billion. 98% is 12.25 million, billion, sorry, 12.25 billion. And 99 is 24750. And I'd like to do a couple more where I put in really close to 100%. What if I want 99.9% of the pollutants removed? That's going to take 249,750, 249 billion, $750 million. And then what if I want 99.99? That says 2.5 times 10 to the 6th, which means move the decimal 6 places to the right. So I get 2, 5, and then 5 zeros to move the decimal 6 places to the right. So that's $2.5 trillion. Yeah. All right, what happens? Let's see what happens when I try to type in 100. It says error. And if I want to try to take out 100% of the pollutants from the river, I get an error in my calculator. What does this tell you about the cost of cleaning up the river's pollutants, this table, and the fact that you get an error for 100%? It's not possible. Yeah. It gets more and more expensive the closer you get to 100%, and you actually can't get all the way to 100%. %100% clean is impossible, and it's very expensive to get close. So think about that expression. Why can't I put a 100 in there? I have 250x over 100 minus x. What happens if I try to put in 100 for x? You'd be dividing by 0. Yeah. It would be 25000 over 0. This is an undefined amount. Everybody remembers that? You can't divide by 0. So what we say about this rational expression is that it is not defined for the value x equals 100. Try to put 100 in there and you get an undefined expression. Okay, so an important concept that you may or may not have seen before is that of domain. A domain is an expression, the domain of an expression is the set, right? We talked about sets last class. Is the set of all real numbers for which the expression is defined or can be evaluated or makes sense. So for example, the domain for the rational expression that we were just working with is the set of all real numbers except for 100. you can put any x value in there except for a 100. So if I were to use set builder notation to describe that, it would be the set of all x's such that, right, you do the curly brackets, the set of all x's such that x is not 100. So that's just the fancy mathematical notation to say all numbers except for 100. All x values are cool to put in there except for 100. Yes.
Like over 100.
Over what? Over 100?
If you were to, this is a all numbers but 100 word in the expression. If you put in a number over.
Oh, okay. So for our purposes, where that thing was representing percent, right? You can't remove more than 100% of the pollutants in a river. So the real life domain will often use different words for a real life situation and for an abstract mathematical situation. So if we were using this expression to describe the real world domain, I would have written it as the set of all x's such that x is less than 100 and bigger than or equal to 0, right? Because you can't remove more than 100% of stuff. So this one is the real life, right? But if that expression didn't have a story tied to it, if I just gave you that in a quiz with no story, right, and asked you what its domain was, mathematically, the only x value that you can't put in there is a 100. Okay, so this is what the domain would be if there's no story attached to that expression. Yes. Why is it different? Okay, so forget the story for a second. You look at this expression, 250x over 100 minus x. The only thing that would make that expression break, right, is if I tried to put a 100 in for x because I'd get a 0 denominator. If I put in 300, you can do 100 minus 300. It works, right? So the only thing that would make this expression not make any sense is a 0 in the denominator, which would happen if x is 100. But in the real life situation, it doesn't make sense to put in something bigger than 100 because 100 is 100% and you can't have more than that. Yeah. All right, so think about rational expressions and the one we just worked with as an example. When can a rational expression not be defined or evaluated? What would make a rational expression undefined? 0 in the denominator. That's the only thing you have to worry about with a rational expression. Those are the only values that can't be put in are places where the denominator are 0. So let's try to make one up. Let's try to make up a rational, sorry, I keep using the word function and you don't know that yet. Expression. Let's make up a rational expression that has a domain where all real numbers except for 10. 10 would like make a black hole and the universe would end, right? Any expression where the only number you can't put in is x equals 10.
Say 15 over 9 minus.
Great. You can't put a 10 in there. If you try to put in a 10 for x, you get a 0 in the denominator, world explodes, right? Anything over 10 minus x, or anything over x minus 10, right? Either way, if you try to put in a 10 for x, you get a 0 denominator. Any of those things will make the denominator 0. So the domain would be all real numbers except for 10 in all three of those examples. Okay, so you set the denominator of a rational function equal to 0 to find out the numbers that must be excluded from the domain. You just have to find out what x values will make the denominator 0. So I'll do A with you, and then you can do B. So x over x squared minus 25. What values of x would make that denominator 0? 5 and negative 5. All you got to do is take your denominator, set it equal to 0, and you can either factor that, x minus 5, x plus 5, and set each factor equal to 0, or you could square root both sides and say x is plus or minus 5. So the domain of this expression is the set of all x's such that x does not equal positive or negative 5. Either of those values would make your denominator 0, so they are excluded from the domain. All right, take a couple minutes in your groups to figure out what the domain is of the next expression. Here's where I wanted you to review a little bit of factoring before today's class. Okay, so to find the places, the x values that will make the denominator 0, set the denominator equal to 0 and solve it. Okay. So you could use factoring or the quadratic formula. Right? So just pick your favorite method here. This factors to x minus 8, x plus 2. And once you factor, the whole reason that you factor a quadratic when you have it equal to 0 is that if you multiply two things together and you get an answer of 0, it has to be that one of them was 0. That's the only way to get 0 as the answer to a multiplication problem. So either x minus 8 equals 0 or x plus 2 equals 0. You solve each of them separately and you get x equals 8 or x equals negative 2. Yes?
What if it was x plus 8?
If you had x plus 8 and x minus 2, then when you did the outer and inner parts of FOIL, you would get negative 2x plus 8x, which would give positive 6x as this middle term. So let's x plus 8, x minus 2. So when you FOIL it, right, you do this part and you get x squared. And then you do the outer and you get minus 2x. And then the inner and you get plus 8x. And then the last and you get minus 16. So these guys combine to make positive 6x. But our expression had negative 6x. So you just flip the signs and get the negative. All right, so these values, 8 and negative 2, those are the values we have to exclude from the domain. Those are the only two values you cannot put in for x. So my domain is going to be the set of all x's such that x is not 8 or negative 2. Okay so far? Okay. All right, so we're going to do some simplifying of rational expressions. And simplifying rational expressions, while it looks a lot uglier and scarier, works exactly like simplifying fractions that you learned how to do, you know, probably sometime at least a few semesters ago, if not longer than that. So we want to be able to reduce a rational expression, so we need to know how to reduce a fraction in order to be able to do that. So 12 over 15, how do you reduce that? Divide each by 3. Okay, so why 3? They both go into, 3 goes into both 12 and 15, the numerator and the denominator. So really what you're doing is you're factoring, right? The numerator and the denominator. You're rewriting 12 over 15 as 3 times 4 for the numerator and 3 times 5 for the denominator. Rewriting it using a common factor. Right? So 3 goes into both, so you can write it as 3 times 4 and 3 times 5. The 3's cancel because 3 over 3 is 1. And you're left with 4/5. Everybody's okay with that? All right. So before moving on, this part where I did the 3 over 3 and called that 1, we call that a foo-foo, a fancy form of 1. 3 over 3 is a fancy form of 1, or a foo-foo. Okay, so to simplify a rational expression, you do the exact same thing you did with a fraction that just has numbers in it, almost. It looks less familiar, but the concepts are the same. The key to reducing a rational expression is to factor, 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 okay, as much as you can. So here are the steps. First, identify any excluded values from the domain. So first, you got to figure out if there's any x's you can't plug into this thing. Second, factor the numerator and the denominator completely. Factor as much as you can. Third, identify any common factors that are foo-foos, right? Anything you have the same on the top and the bottom, and cancel them. Okay, that's the last step, cancel. Okay, so I'll do, actually, why don't you just go ahead and try A. Just go ahead and try it. Factor, 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 cancel, cancel, cancel. See if you can simplify it. Okay, so let's look at these couple of things together. So first thing we have to do, mandatory, right? First step is identify any excluded values from the domain. So the first thing we do is we set the denominator equal to 0 and solve it. Find any values of x that would make the denominator 0. So we're not even reducing yet. We're just figuring out the domain. So we said x squared plus 2x minus 8 equal to 0. Make the double bubble. All right, so I have a 1 coefficient on my x squared, so that means I just need to think of two numbers that multiply to -8 and add to +2. What do you think? -2 and +4. X minus 2, x plus 4. So FOIL it just to check. You get x squared plus 4x minus 2x gives me the +2x minus 8. So then you say, okay, x equals 2 and -4. Set each of those factors to 0 and solve. And so these are my excluded values. So my domain is the set of all x's such that x does not equal 2 or -4. And you can write or you can use a comma. They're both acceptable. All right, so to reduce this thing, to simplify it, to reduce it to lowest terms, factor everything and cancel as much as you can. So x squared plus 3x minus 10. Do this on a new page. Over x squared plus 2x minus 8. Okay, so factor, factor, factor. So my numerator, make my double bubble, put my x's in, and then I need two numbers that multiply to -10 but add to 3. -2 and +5, good. And then this one we already factored when we did the domain. This was x plus 4, x minus 2. Do I have any foo-foos? Yeah, I have x minus 2 on the top and the bottom. That's a fancy form of 1, right? Because one thing divided by itself is 1 that cancels. And so you're just left with x plus 5 over x plus 4. Okay. Now, can I say x plus 5 over x plus 4, cancel the x's, 5/4? No. No, 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 no. Okay. So this is like, if you leave this class with anything, please let it be this. Okay. This is a really, really common mistake. You can't do this. Okay. And, sorry, go ahead. 2 plus 4? Yep. Yeah, we excluded some numbers from the domain, right? Yeah. Yeah. Oh, no. That's why I make you do this first, because once I simplify this, it's equivalent to x plus 5 over x plus 4. Those things are equal, except that this original one has a domain that's different than this one, right? So this original one, you can't put in a 2 or a negative 4. So if you did that, if you found the domain last, right? If you did the reducing and then said, oh, and the domain of this resulting thing is all x's except for negative 4, you'd be leaving one out, right? Because for these two things to be exactly the same, they have to have exactly the same domain. So these are equal, and this domain applies to the result. That's why I make you do it first, so you don't forget one. Your domain is just the bottom factored out. Take out any x's that make the denominator 0. Okay, x plus 8 over x plus 4. Can I factor that at all? No. Any foo-foos? Can you divide the 8 and the 4? Can you divide the 8 and the 4? Nope. You can't cancel the x's. You can't cancel the 8 over the 4. This is, we call this prime, right? You can't reduce anything any further. Or you could say it's already in lowest terms. Let's just say, pick a number for x. If you're ever in doubt, can I cancel in this situation? Pick a number for x and test it, right? So I have x plus 8 over x plus 4. What if I put in for x if I put in 6, right? So if I have 6 plus 8 over 6 plus 4, right? If you were just going to evaluate that, 6 plus 8 is 14, 6 plus 4 is 10, 14 tenths or 7 fifths, right? If I tried to cancel the 6's and 8 fourths and was left with 8 fourths, which is 2, right? It's a different answer. If I tried to cancel the 8 and the 4 and did like 6 plus 2, that's 8, which is different than this, right? So this is the real answer. You can't cancel the 6's, right? So some people might say this is 3. Can't 1 plus 2, right? 3. No, this doesn't work. So if you're ever in doubt, pick some numbers and check to see what's allowed to be canceled and what's not. Okay, I'm going to have you do this little summary thing. Maybe we'll do it together. Okay. So what's your process for adding or subtracting two fractions? Like, what's the first thing you have to do no matter what? You need a common denominator. To add or subtract, you need a common denominator. Common denominator, then what do you do to add or subtract two fractions? Add or subtract the numerators, leave the denominator the same, right? So, quick example. We'll do one together. Let's say I wanted to do 1/6 plus 1/2. What would my common denominator be? 6, right? So you think about factoring, you'd go, okay, 6 is 2 times 3. So to make my common denominator, I'm going to take the 1/2, multiply by the foo-foo, 3 over 3. And so you end up doing 1/6 plus 3/6, which is 4/6, or 2/3. Is that okay? All right, so let's do an equivalent kind of problem. I'm going to go to B here. Similar kind of problem, trying to subtract two fractions. I have to figure out the common denominator. To do that, factor everything, right? Just like in your head, when you looked at that 6, you factored it and said, oh, that's 2 times 3, right? You don't always write that out when you're dealing with numbers, but we're going to do that when we do the rational expressions. So I've got x over factor x squared plus x minus 2. I'm going to say x plus 2, x minus 1. And then minus 2 over x squared minus 5x plus 4, x minus 4, x minus 1. Okay, do these two fractions, the two denominators, do they already have any factors in common? Yeah, what factor? Okay, they both already have an x minus 1. So I don't have to give either of them an x minus 1 factor. They both already have one. Okay. But if I wanted these two denominators to be the same, this fraction on the right, I would want to give its denominator an x plus 2. And I have to multiply the top and bottom by that. And then, so if I give this denominator an x plus 2, it now has an x minus 4, an x minus 1, and an x plus 2. So anything that the other fraction had that this one doesn't already, you have to give to it. And vice versa. This one already has an x plus 2 and an x minus 1. It needs an x minus 4 to make it look like the other one. So our foo-foo for my fraction on the left is going to be x minus 4 over x minus 4. So now I have x times x minus 4, that's x squared minus 4x, over my common denominator, which I'm not going to bother multiplying out. I'm just going to leave it x minus 4, x plus 2, x minus 1, minus 2 times x plus 2 is 2x plus 4. And I have my common denominator, x minus 4, x plus 2, x minus 1. So I've got a common denominator. Does the process of getting that common denominator make sense? Okay. All right, so now I just have to subtract the numerators. So I have x squared minus 4x minus 2x plus 4, and there's some sort of invisible parentheses right there to distribute that negative to. So I have x squared, that's my only squared term, so x squared. Then I have negative 4x minus 2x. What's negative 4x minus 2x? Negative 6x. And then I have nothing, right? 0 minus 4. So 0 minus 4 would be negative 4. Because of this subtraction sign, that 4 is really minus 4. And that's all over my common denominator. X minus 4, x plus 2, x minus 1. And that's it. You might, if you were done, try to factor x squared minus 6x minus 4 and see if you have any foo-foos. But x squared minus 6x minus 4, I don't think cancels. I mean, I don't think factors. Could you factor that? You need two numbers that multiply to 4 and add to 6. The only factors of 4 are 2 and 2 or 4 and 1, so that doesn't factor. So we're done. So that's the adding and subtracting rational expressions. Just like adding and subtracting fractions, it just looks scarier, but it's the same. All right, what about multiplying and dividing fractions? I'll write this on a new page. Multiply or divide? We'll just do multiply. How do you multiply two fractions? Yes. Multiply both the numerators and the denominators. So for example, if I wanted to do 2/3 times 4/7, multiply the tops. 2 times 4 is 8. 3 times 7 is 21. Multiplying fractions way easier than adding and subtracting fractions. So what about dividing? How do you divide two fractions? Multiply by the reciprocal. Okay, so by the reciprocal of the denominator. Right, so if I wanted to do 1/3 divided by, I don't know, 1/2, right? I would say instead do 1/3 times 2/1. I'm just going to say multiply by the reciprocal. And that would come out to 2/3. Familiar process, right? Everyone remembers? To divide two fractions, just multiply by the reciprocal? Okay. So let's do one with a rational expression instead. The key is to factor when you're find foo-foos. Okay. So I'm dividing two fractions. I'm going to factor everything as much as I can. And instead of writing divided by that second fraction, I'm going to multiply by its reciprocal. Okay, so I'll start out by factoring. So x squared minus 25, that'll factor to x minus 5, x plus 5. X squared minus 16, that's the difference of two squares. It factors to x minus 4, x plus 4. And then divided by, factor everything in the second fraction. X squared plus 6x plus 5. I think that'll factor to x plus 5, x plus 1. And x plus 4 can't factor any further, so that's done. Now, instead of writing divided by that second fraction, I'm going to multiply by its reciprocal. So x minus 5, x plus 5, over x minus 4, x plus 4, times x plus 4 over x plus 5 times x plus 1. Now I can cancel any foo-foos. Any factor that appears both in the numerator and in the denominator can cancel. So what factors can I cross out here? X plus 4. I have one in the numerator, one in the denominator. Okay. And all of this is separated by, all of those bubbles are separated by multiplication, so I can cancel as much as I want. If it was addition, I would have to be more careful. All right, what else appears in both a numerator and a denominator? X plus 5. I can cancel those too. Any other foo-foos? Nope. Okay, so I just write whatever's left, and that's my answer. X minus 5 over x minus 4 times x plus 1. You could multiply those together, sure. Yeah, you could FOIL them. Either way that you write your answer would be acceptable. Any questions remaining on how to do that? All right. I have a little activity to close out class with your groups. I want you to determine whether each of these statements is true or false. And if it's false, change it to make it true.